Let's find the domain of this line. Y, or f of x, is equal to 3x plus 2. So to sketch this line, we start at the y-intercept of 2, that's 2 units up. And then we simply think of the slope. Rise over run. 3 up, 1 right. So 1, 2, 3, and 1 to the right. So this is the line. It continues forever and ever. And the domain is how wide this line opens up, sideways. So the domain is all real numbers. All real numbers. All real numbers is the same thing as saying x belongs, it's a fancy little Greek letter here, to real numbers. This means from negative infinity all the way to positive infinity. So this sign represents less than and greater than sign. X is between negative infinity all the way to positive infinity. And this happens to be the same thing as negative infinity all the way to positive infinity with these rounded brackets. The rounded brackets represent the fact that we cannot actually equal infinity. If this was a square bracket, we would end at that point, but infinity is simply an idea, it's not an actual value. Similarly, the range goes from forever to forever, up and down. This line extends towards infinity. From negative infinity, y is between negative infinity all the way towards positive infinity, which means up. So we could also say y belongs from negative infinity all the way to positive infinity, or we could say all real numbers. We have this line f of x equals 2x plus 3. However, the domain constraint is x is greater than or equals to 1. That's given. Let's try drawing this in order to figure out the range. So 3 is the y-intercept. We go up 1, 2, 3 units, and we draw a dot. And the slope is 2 over 1. So we go up 2, 1, 2, and we go 1 to the right, and we draw a dot. So here is our approximate line. It extends forever. Now, the key here is the line extends forever. However, when we're talking about the domain, x is greater than or equals to 1, then we chop off of the line to the left. So yes, the line extends forever, but we need to figure out this critical value here. So we know that the rise and the run, we went 1 to the right because x is greater than or equals to 1. So let's really focus on this point, x equals 1. So when x equals 1, what's the y value? Y is equals to 2x plus 3. So we know that y is equals to 2 times 1 plus 3, which is 5. So this point here is 1 comma 5. And everything to the left of it, this part here of the line, disappears. So focusing on this ray, the ray emerges from this critical point, 1 comma 5. The range we can see is y is greater than or equals to 5. So it says here now in C, graph this ray on Desmos using curly brace notation. So this is the exact same question, but on Desmos, instead of using the alligator brackets, we use curly brace. X is greater than or equals to 1, curly brace. Try it on Desmos. Finally, let's evaluate f of 2. So this is the function y equals f of x, and let's substitute x equals 2. So f of 2 is equals to 2x plus 3, in which we're going to replace x with 2. That's our x value. 2 times 2 is 4, plus 3 is 7. So f of 2 is 7. In other words, when x is equals to 2, and you go up on the graph, the y value would be 7. So we have the point 2 comma 7 is on the ray.